Got another old Pioneer cassette deck. This is a CTF8080. It's a direct load deck, and the complaint on it is the tape moves, but there's no sound. So this one came in from a client who'd like to see if we can get it working. So let's get started. And this tape does have sound on it, and there's no. Also, the lights aren't lighting up on the front here. That's a giveaway right there that the like these lights should light up when you push the buttons in and out. Like the Dolby light doesn't light up. The chrome tape light doesn't light up either. And there's no sound. So, meters light up though, no problem. So let's get the top off this one and see why it's not working. Well, the reason why the tape counter is not turning, as you can see, the midway pulley here on the auto stop mechanism is turning, but the counter itself is not. So the belt is slipping. You can see the pulley, you can see the back side of the pulley here is turning, but this belt is slipping. It could be just that the counter is jammed up. Looks that way. It looks like the counter is jammed. The belt's got some torque, it's just the counter itself. That's beside the problem. Now the last one of these I saw had a problem with the tape counter. This wasn't sending a signal. It was turning, but it wasn't sending a signal back to the auto stop mechanism. So it was stopping after a second or two. But that part's working, and if I stop this from rotating, it should stop. Like that. So the auto stop mechanism on this one is working. It's just that we have no sound. So we got an amplifier problem or a power supply problem. Power supply on this one is the regulator is right here. It's got a regulator transistor over here and some filter caps. So we'll just measure some voltages and see whether we're missing a voltage. The fact that the lights on the front are not lighting is telling me it's a power supply problem, just from looking at that symptom. And since I fixed my old antique Weston digital Nixie tube voltmeter, I thought, what a better opportunity to try it out. So we're going to use the old vintage voltmeter. I'm going to put the fluke away, and we're going to use the old vintage voltmeter on this one. If you look at the schematic, I just printed a portion. I didn't print the whole entire manual or schematic because I don't want to waste all my paper and all my toner, but I just printed off one page of the schematic. This probably is good enough. I believe this little circuit board that I was showing you, that's this portion right here. And what we have on this circuit board is we have regulators. So we have a couple of full wave bridge rectifiers. They're using dual diodes, two of them, to form the 4 diodes for the rectifier. So the transformer goes into the 2 sets of diodes to give you your 19 volt DC supply, and then this supply goes off to power up circuits that require the 19 volt supply. And then there's also a second, there's actually 3 secondaries. There's one secondary which is just using AC output to light up the panel lights. So they're 8 volt bulbs. There's one fuse that protects that, and then this is the other winding, which actually has 2 fuses on it. This one's got 1 fuse that protects this 19 volt circuit. This other one actually has 2 separate fuses. It's using just it's a full wave bridge rectifier again, but it's doing it with just 1, and it's because they're using a center tap on the transformer, whereas on this side they're not. So on this side they need 2 dual diode rectifiers, one to rectify the positive half and the other to rectify the negative half. But on this other side we have just 2 diodes. Looking for my Sharpie to point this out, my highlighter on this will work. Okay, so we have our AC coming off the transformer, one side of it, the center tap here, is grounded, as you can see. We have our dual diodes, and we have the positive swing of the AC waveform is going to pass through the diode one direction only. So when this side is positive, this side's negative, the diode is going to block. It's going to let the positive voltage go down, and then when the AC waveform reverses, this side is going to conduct and provide the positive voltage. It's going to give us 36 volts right here on C470. C470 goes through our regulation circuit, and it'll go through R560, which will charge up this C702, and then it also continues through R560 here to provide a bias voltage for Q701. This is our regulator transistor right here. So we should have about 36 volts here. We should have about 25 volts here, and that should give us 24 volts here. And this gives us our 24 volt supply, which is then sent out to the rest of the circuit. So concentrating in probably this area here. We'll see if the 19 volt supply is present. This one's unregulated though, so unless we had an open fuse, this one should be 19 volts. So let's just do some voltage measurements in this circuit and see where the problem is. A couple problem areas: we could have a shorted filter capacitor here. This capacitor could certainly short. That one there could certainly short. And of course this Zener diode here could short. If either of those were to short, it would kill that 25 volt reference, and that transistor would turn off. Transistor itself also could be open. So if we have our bias voltage here, if we have like 36 volts here and 25 volts there and 0 volts over here, then the transistor itself is likely open. But if we don't have any voltage here on the base, then there won't be any voltage on the collector. So we may have a shorted cap or a shorted Zener diode. One of the two, I would think. Or it could be this resistor here. This resistor also certainly could be open, because that provides the reference voltage. So it could be this resistor here could be open, or this resistor could be open, or that cap could be shorted, or that cap could be shorted, or the Zener diode shorted. It's going to be one of those 5 components. So we'll look for the 30 volts here first. Well, we'll look for our 24 volts. But if we have 24 volts, we'll look for our 30 volts here, and that'll tell me whether this cap is shorted or not. So let's look. I'm going to try and frame this to keep the antique voltmeter in view. So let me turn on the power, and the first place I'm going to check is I'm going to check for the, what I say was the 24 volt rail. And that should exit. We'll just check what voltages are actually exiting the board here first of all. So here's voltages leaving the board. That should be ground. I have nothing leaving the board. Okay, 24 volts there. Negative 24. If we look, the little negative sign is on here. See the negative sign? It's negative 24. And this is positive 21 is lighting up there. So that supply, the negative supply there, and this positive supply is running, but I see nothing over here. And I'm sorry if my head's getting in the way. I'll try to get out of the way here. Try to show you that again. I don't know if my head was blocking the shot or not, but we have positive 22 volts. That's the 19 volt supply, as Mr. Multimeter is showing. And we have negative 24.8. But I have nothing over here. This should be one of these should be the 24 volt or 25 volt output. So let's look at negative 24, negative 37. That resistor's not open. Where is the other one? They're over here. They're in the back of this one here. What do we got down here? It's hard to get the probe in. Gonna pull that little circuit board out. Buddy Amazon drivers driving like maniacs. Okay, here is our resistors that we can actually measure right on the transistor here, and this will give us an idea of whether we have any drive or not. So I've got the power plugged in. Let's just measure the transistor. What am I looking at? I'm going to look at the collector. The collector should be at 37 volts, which it is. The collector is also connected to the heatsink because there's no shield on it. And we have a base drive and an emitter. Whoops. 0, 0, 37. 0.5. Well, that's just the meter itself floating. I have to zero this meter out. The meter, this is, I have zero controls on here to zero the meter out. Oh well, I got the wrong screwdriver. Anyway, yeah, these old meters, you had to zero them. Anyway, I've got 37 volts here. I got nothing on either side. So I'm thinking either the Zener is shorted or the cap is shorted. That's what I'm thinking. So here we are right there, and I've got 0 volts on the base, and therefore I'll have 0 volts on the emitter. So could be the resistor open too, but what are the chances of a resistor going open? How many ohms is this thing? 560 ohms, half a watt. That'd be one of these ones here. Which one is it? It's looks like this one here. So 560 ohms, half a watt. We'll do it with this meter here. See what it shows. Now we know this meter's not all that accurate, ohms, but it's measuring 630 ohms. I think the resistor is probably okay. It's not open. Neither is that one. Measuring 600 ohms as well. If it was open, it would be much higher than that. I'll check it with my flute just to make sure, you know, because, hey, old meter, right? Old meter. We'll see how accurate the fluke is measuring in circuit. Okay, like 543. The resistor is okay. Let's measure across that capacitor. Well, the Zener and the capacitor. Okay, it's shorted. Yeah, I used the flute that time just because I did. The other one will show me as well if I put this one on here. If I were to measure across here with this one here, it's going to show that it's, you know, it's shorted. 0.1 ohm, right? 0.01 ohm, it's shorted. Dead short. So I'm thinking capacitor or Zener. We'll pull the cap out first and measure that and see whether the cap is shorted. And maybe that's the one that's gone bad and the Zener is okay. So let me just heat up the soldering iron. We'll pull the cap out and check that and see what, well, I'll check it and see if the short goes away when I disconnect it. How's that sound? If I disconnect one lead and the short goes away, then we know that the cap is shot. So let me just do that. Okay, I've disconnected one side. Let's see if it's still got a short. If it doesn't, then the cap is bad. Oh, it doesn't have a short. It can actually measure the Zener diode. We'll have conduction in one direction and not the other. Okay, conduction in one direction. That's probably the transistor I'm seeing there. Oh, it's charging up. Anyway, it's not shorted. Not shorted anymore. So I have a sneaking suspicion that that cap is the problem. So let's take it out and change it. Should be able to measure it out of circuit too and see what it looks like. to get it out of here. My mistake, it was actually the Zener I unsoldered. So I don't know where that diode junction, I guess it was across the transistor, is what I was seeing. But yeah, it's the Zener that's shorted, not the cap. Listen, see? The Zener shorted. So let's find a new, it's a 24 volt Zener. Let's find a new one. Wish me luck. I'm sure one of these is going to be a 24 volter somewhere in here. Got a whole bin full of caps, or not caps, Zeners and regular diodes as well, but many of them have been installed before. But I'm going to go look through here and see if I can find one. I got to look up the numbers on them, right? Because I need to find a 24 volter. Okay, I've got one. I'm going to put the insulation tubing from the original one onto this one. This is just to prevent it from shorting out. Can't see what I'm doing. Gotta get the light in here so I can. There. Okay, now that that's in place, let's put the meter back on in voltage mode. I'll use the old meter again for this, and we'll see whether the voltages come back. So what I'm looking for is the 24 volt supply. Where's my probe? It's over here. Ground. So I'm looking for my 24 volt supply off of this pin here, the emitter. And turn on the power. 24.9 volts. That's meaning it's working. So if we look at our supply here, we've got 36 volts on the collector, 25.8 on the base, and 25.3 on the emitter. So I'm going to put the board back in, and then we'll test this unit and see if I get sound, which I should at this point. Should have sound. And then maybe I'll look at that tape counter that's not turning, because it looks like it's sticking. That wire appears to have broken right from there. So we'll solder that wire back on. They use wire wrap on the original, but I'm not a big fan of wire wrap. Too hot out here today. It's 30 degrees. Another little heat wave here in the province. Let's see if I get sound off this machine. See if it'll play a tape. So the chrome lights light up on this one now, which is good. Let's just check it out. Gotta fix the tape counter now. I'll try a new belt first. That's the easiest thing to do, is just to swap the belt out and put a little tighter one in. Try this one. This is another belt. This is not a very tight belt, because you don't need a tight belt for the tape counter, as long as it turns it. As you can see the tape counter is moving now. We're going to do a quick recording on this unit and see how it sounds. Record and play together, release the pause, and record. So like before, I'll record this track, and then we'll play it back and we can listen to the full track, beginning to end, off of tape. I'm recording this without using any Dolby, so you'll hear some tape hits, but I want to hear how this deck actually sounds. And yes, I did clean the head off camera, but I have not demagnetized it. Because this being a two-head deck, demagnetization is not really necessary. As soon as I put this into record, the bias field will instantly remove any magnetism from the head, so not necessary on a two-head deck. Okay, we'll rewind the tape back. We'll turn on the memory stop. Okay, we're going to plug it into the camera directly. We'll take a listen to sound right off the tape. Okay, that boat does it for this one. I'm gonna throw this one back together and give the guy a call and let him know he can come and pick up his boat anchor, because that's what these things are. These things are boat anchors. We'll catch you in the next one. Bye.